Good morning, dear students. Today we'll continue with part 3 of the chapter 4 carbon and its compound. In today's lecture, we'll try to finish the things off. Okay, in this lecture, only two topics are remaining, that is the homologous series and catenation. But in last lecture, we have seen the alkane and alkene family. Now, in this lecture, we're going to see alkyne family first, then we'll start catenation. Now, as we have discussed, the general formula of alkane is CnH2n plus 2, alkene is CnH2n, and the general formula for alkyne is CnH2n minus 2. CnH2n minus 2. Now, first thing, what is alkyne? Alkyne is a compounds in which the carbon-carbon triple bond is present. The organic compound in which there is a triple bond between the two carbon atom is known as alkynes. As you can see here, C triple bond C. Whenever we see C triple bond C in any of the organic compound, we can see or we can say that it is belongs to the alkyne family. Okay. Now, can we draw or can we have the formula of methyl on the basis of CnH2n minus 2? Methyl. So the formula of methyl is not possible because in alkyne there is triple bond between two carbon atoms. So minimum two carbon atom required for the alkyne family. So we'll start with the alkyne with the ethene, or we can say not ethene, it is ethyne. In ethyne there is two carbon atom. We know that there is two carbon atom, and the triple bond present between the two carbon atom is known as ethyne. Now, the valency of carbon is 4, but here triple bond is present between the two carbon atom. If we see this carbon atom, this contains 1, 2, 3 bonds, and we know that the valency of carbon is 4, therefore it will have one more bond, that is with hydrogen. Now we will discuss about this carbon. This carbon contains 1, 2, 3 covalent bond, so it will have one more bond, hydrogen. Now we can see that for this carbon there is 4 bond, 1, 2, 3 and 4, and for this carbon there is 4 bond, 1, 2, 3 and 4. That is the valency of both the carbon have been satisfied. Now if we draw the structure of propyne, in propyne, as we have discussed, whenever there is a 3 carbon atom, then the organic compound is known as propyne. Methane, ethane, propane. If we draw a triple bond between any carbon, for example, we draw a triple bond here. Okay. Now we'll satisfy the valency of carbon with the help of hydrogen. Now this carbon contains 1, 2, 3 bonds, so this will contain one more bond. So the valency of this carbon has been satisfied. Now we discuss about this carbon. This carbon contains 1, 2, 3, and this is 4. Now the valency of this carbon has been satisfied. What about this carbon? This carbon contains only one bond, and the valency of carbon is 4. So this carbon will contain 3 more bond with the hydrogen. So this is the formula for propyne. Or you can see, if I draw the triple bond between this and this carbon atom, the similar formula will be formed. We can have the triple bond between these two carbon also. So this carbon contains only one bond, so this would have 1, 2 and 3 hydrogen. This carbon's valency is already satisfied because 1, 2 and 3. And this carbon valency is 1, 2, 3. So this would contain one more hydrogen. So the structure of propyne can be drawn like this. Similar way, we can have the structure of butane. See, whenever we are writing the alkyne family, there is a suffix YNE, that is ion. So in case of butane, there is 4 carbon atoms: methane, ethane, propane, butane. But since we are drawing for alkyne, we can have triple bond between any of the two carbon atoms. So we will draw a triple bond between these two carbon atoms. Clear? Now, this carbon contains one bond, so this would have three more bonds. This carbon balance is already satisfied because 1, 2, 3 and 4 bonds are present. What about this carbon? This carbon contains 1, 2, 3. So this would require one more bond, that is covalent bond. So the valency of this carbon is also satisfied. What about this carbon atom? See, whenever the carbon atoms are present at the adjacent sides or at the last point, this is known as terminal carbon atom. Whenever carbons are present one after the other, they are known as terminal carbon atom. But the carbon which is present at first and last, they are known as terminal carbon atom. Now this carbon contains one bond, so this would require three more covalent bond. So this is the structure of butane. By this way, you can draw pentyne, hexyne, heptyne, octyne, nonine, and decyne. So we have seen how to draw the structures of alkyl family. Clear? Now we are going to see the main topic of this chapter, that is catenation. What is catenation? Now, what is catenation? Catenation is the remarkable property of a carbon to form a bond with itself and draw straight chain compound, branch chain compound, and cyclic compound. That property of carbon is known as catenation. If we want to write the definition of catenation, we can write the remarkable property of carbon atom to form bond with itself the remarkable property of carbon atom to form bond with itself, and when carbon forms bond with itself, it can form either straight chain compound, branch chain compound, and cyclic compound. So to form bond with itself, to form straight chain compound, like C dash C dash C dash C. Okay. Or it can form branch chain compound. How to form branch chain compound? For example, if I draw this structure in form of the branch, one of the carbon atom have been branched. This is known as branch chain compound. And it can also form cyclic compound. Cyclic compound. The carbon will arrange in form of the cycle. For example, C dash C dash C dash C. This is the cycle. Or the carbon can be arranged in form of pentagons. This is the cycle. Or the carbon can be arranged in form of the hexagonal structure. Okay. So this is known as cyclobutane because four carbon atom is present. 1, 2, 3, 4. Methane, ethane, propane, butane. So this compound name is cyclobutane. This is cyclopentane because 5 carbon atoms are arranged in form of 3, and this compound is known as cyclohexane. This compound name is cyclohexane. So the remarkable property of carbon atom to form bond with itself. Carbon form bond with itself and it forms the straight chain compound. That means carbons are arranged in form of a straight chain C dash C dash C dash C. And the carbon can form a branch chain compound like C dash C dash C, and one of the carbon is branched, or we can draw C dash C dash C dash C dash C and dash C. This is also a branch chain compound. Clear? So the remarkable property of carbon to form bond with itself, or it forms the straight chain compound, branch chain compound, or cyclic compound is known as catenation. So whenever the question is asked for 2 marks, define catenation and give example. You can write this definition and you can write these 3 examples Now the next topic we'll see in this chapter, that is homologous series. Very important topic. Homologous series. What is homologous series? Homologous series means what? A group of organic compounds. Whenever there is a group of organic compounds and each member of that group is differed by one carbon atom and two hydrogen atom, then that series is known as homologous series. Okay. First I will define what is homologous series. Then we will see the examples of homologous series. So I can write the examples of or the definition of homologous series. The group of organic compound in which each member of group is differ by one carbon atom and two hydrogen atoms. A group of organic compound in which each member of group is differ by one carbon atom and two hydrogen atom. One carbon atom and two hydrogen atom is known as homologous series. Okay. Now we'll see the examples of homologous series. Okay. Now the examples of homologous series I can draw. I hope you have written this definition. For example, I write alkane family. Alkane family. And here I write the difference. Now first I draw the methane, then ethane, C2H6, propane, C3H8, C4H10, and C5H12. This is the alkane family: methane, ethane, propane, butane, and pentane. Now focus on this. What is the difference between these two? Here it contains one carbon and it contains two carbon. That means here the difference of one carbon. This contains four hydrogen and this contains six hydrogen. That means how many hydrogen have the difference? So two hydrogen, four hydrogen and six hydrogen. So there is a difference of two hydrogen. Now we'll see in between ethane and propane. This is C2, this is C3. One carbon is extra in propane and this is H6 and H8. That means two hydrogen is extra, that is CH2. If we see, this is also differed by CH2 and if we see, this is also differed by CH2. That means a group of organic compound in which each member is differed by one carbon and two hydrogen is known as homologous series. Clear? You can write the examples of alkene family or you can write the example of alkyne family. So this is the homologous series. Now one more thing, by how many or by how much the molecular weight they differs. By how much molecular weight they differ. See, the weight of carbon is 12 and hydrogen is 4. So its weight is 16. If I write one carbon having 12 gram, so two carbon, that is 24 and 6, that is 30. So what is the difference? The difference is 14. The difference is 14. So each member having the difference of 14 atomic mass unit. Clear? So homologous series is a group of organic compound in which every member is differed by CH2 group and their molecular masses is differed by the 14 atomic mass unit. This is all about the homologous series. I hope you have understood this chapter very well. Okay. Now we have finished this chapter. I hope you have understood. If you have any kind of doubt, you can ask me at the